Hello and welcome to this video on machine learning life cycle. As we know, machine learning has given the computer systems the abilities to automatically learn without being explicitly programmed. But how does a machine learning system work? So, it can be described using the life cycle of machine learning. Machine learning life cycle is a process to build an efficient machine learning project. The main purpose of the life cycle is to find a solution to the problem or project. So these are the learning outcomes of this video. On completing this session, the learners will be able to list various phases in machine learning project and explain significance of each step in ML life cycle. So let's get started. So let's see first all these phases. Phase 1 is business understanding and planning. Second is data collection. Third step is data preparation. Next, data exploration. Fifth step is data modeling. Next, presentation and deployment. And last step is monitoring and maintenance. So let's understand now all these phases of machine learning life cycle. As we know, the first step is business understanding and planning. The most important thing in the complete process is to understand the problem and to know the purpose of the problem. The good result of the project depends on the better understanding of the problem. Thus, the planning phase involves defining the objectives and producing the project plan. It further involves assessing the scope of the project, success metric, and feasibility of the machine learning application. You need to understand the business and how to use machine learning to improve the current process. You need to figure out how machine learning can add value in the business. The next step is to collect the data. We need to first decide how we will be collecting the data. There are various sources of data. We may gather the internal data. We may use some open source data. Even we can buy it from the vendors, or we may even generate synthetic data. Each method has some pros and cons, and in some cases we get the data from all these four methodologies. After collecting the data, we need to appropriately label the data. The data collection and labeling require most of the company resources, money, time, professionals, subject matter experts, and legal agreements. Thus, this phase includes several tasks like identifying various data sources, collecting the data, integrating the data obtained from different sources. By performing these tasks, we get a coherent set of data, typically known as a data set. It will be used in further steps. The third step is data preparation. It includes three important tasks: data cleaning, data transformation, and combining the data. So let's understand the task of data cleaning. Whenever we collect data, usually it is raw data containing almost all the attributes. Those can be extracted in the process. However, raw data has several problems, and that is the reason why we need to clean the data. This process involves removal of unwanted observations, fixing structural errors, managing or removing the outliers, and handling missing data by imputing the values appropriately and analyzing wrong labeled data. Next task in data preparation is data transformation. It refers to the process of converting raw data into a format that is suitable for analysis and modeling. There are two kinds of data transformation processes. First is mandatory transformations and second is quality transformation. Mandatory transformations are typically for ensuring data compatibility. The examples include converting non-numeric features into numeric features. You can't do matrix multiplication on a string, so you must convert the string to some numeric representation. So such kinds of transformations are required to be performed. Next, Many times, we may require to resize the inputs to a fixed size. Such kinds of transformations are mandatory transformations, and those we should perform to ensure data compatibility. The next kind of transformations are optional, and those are required to improve the quality or performance of the model. The examples of such transformations are tokenizing the textual features or lowercasing the text features for maintaining the uniformity among the data. Also, some of the transformations are normalization or scaling the data. Normalizing and scaling the data is essential to improve upon the performance of the models, and these are the optional but very important kinds of transformations. The next task of data preparation is combining the data. Many times the data is stored in separate files or in separate tables. Enriching data refers to adding and connecting the data with other related information to provide deeper insights, and this is one of the important tasks under data preparation. The fourth step is data exploration. The data processing stage involves data analysis, feature engineering, and data visualization. You need to know the patterns in your data and determining which variables are important and which do not play a significant role in producing the output. Further, some variables may have correlations with other variables, demonstrating redundancy in the data. Visualization of data helps in the process of identifying such kinds of redundancies or extraneous attributes. All of this can be done with exploratory data analysis. It helps you gather insights and make better sense of the data and removes irregularities and unnecessary values from the data. Thus, data exploration helps you prepare your dataset for analysis, gives you more accurate results, and it also helps to choose a better machine learning model. After analyzing the data and gaining the insights from the data, the next step is data modeling. Model building is the process of developing a model that best describes the relationship between independent and dependent variables. Independent variables are the features that are describing our data, and the dependent variable is the variable that we would like to predict. Various machine learning models are to be built based on the problem statement. Initially, dataset needs to be partitioned for training and testing. We need to explore several machine learning models like k-nearest neighbor algorithm, decision tree, or Naive algorithm, and many more. Further, these models need to be evaluated for their performance. Model validation and evaluation involves testing the model, tuning the model parameters, validating the model. Model evaluation involves bias variance trade-off and looking at model underfitting or overfitting and to ensure the appropriate performance of the model. So based on all these validations and observing the model performance, finally we select the appropriate model for solving the problem. Excellent. You have got a brilliant model ready to go to production. Now you are supposed to communicate and present your results to the business head. And once it gets approved, your engineers need to deploy a trained model and make it available for external inference requests. For example, if you are working on the project for automating warehouse labeling using the shape of the product, you will be deploying a computer vision model into the current system, which will use the images from the camera to print the labels. Generally, the models can be deployed on the cloud and local server, web browser, packaged as software, and edge devices. After that, you can use APIs, web applications, plugins, or dashboard to access the prediction. In the deployment process, you define the inference hardware. You need to make sure that you are having enough RAM, storage, and computing power to produce fast results. After that, you will evaluate the model performance in production using some tests, ensuring user acceptability. The deployment strategy is really very important. You need to make sure that the changes are seamless and they have improved the user experience. And finally, the seventh step of this machine learning life cycle is monitoring and maintenance. After deploying the model to production, you need to constantly monitor and improve the system. You will be monitoring the model metrics, hardware and software performance, and customer satisfaction. The monitoring is done completely automatically and the professionals are notified about the anomalies, reduced model and system performance, and bad customer reviews if any. After you get a reduced performance alert, you will assess the issues and try to train the model on new data or make changes to model architectures. This is a continuous process. In very rare situations, you have to revamp the complete machine learning life cycle to improve the data processing and model training techniques. Thus, to summarize machine learning life cycle, there are 7 important phases. We have seen the steps like business understanding and planning, which is very crucial in planning your project. Then comes data collection, data preparation, data exploration, data modeling, then presentation and deployment, and monitoring and maintenance. This entire process of building machine learning applications following the life cycle is very interesting, and it has several challenges as well. So I hope you must have gained the insight how actually the machine learning application is being developed following this life cycle. That's all for this video. Thank you.